Good morning to all of you. Welcome back on my channel Shivam classes. Okay, our today's topic is equipotential surface. Now see what is the definition of the equipotential surface. Any surface which has same electrostatic potential at every point is called equipotential surface. Okay, the surface which have same electrostatic potential at every point is called equipotential surface. The equipotential surface can be drawn through any region in which there is an electric field. Obviously, if there is an electric field, that only we can draw an equipotential surface on that place. Okay, now see what is the next. If all the points are same, if all the points at same potential in the electric field are joined, then an equipotential surface is obtained. Okay, so in equipotential surface, the potential is equal at all the points. The shape of the equipotential surface through any region due to. Okay, now we will see what are the shapes of the equipotential surface. Okay, so first shape is line charge if it is cylindrical. Okay, suppose the charges are linear. Okay, then what will be the shape of the equipotential surface? Cylindrical. Okay, like this. Okay, these are the linear charge and this is the cylindrical shape of the equipotential surface. Okay, now second one is point charge if point charges is spherical. Okay, suppose there is a point charge, then what will be the shape of the equipotential surface? Is spherical. Okay, suppose this is a point charge and this is the shape of the equipotential surface. Okay, and that is spherical. Okay, now see the next topic, properties of equipotential surface. Okay, now we will see what are the properties, what are the particular properties of the equipotential surface. Okay, so equipotential surface do not intersect each other. What is the first point? What is the first property of equipotential surface? Equipotential surface do not intersect to each other as it gives two direction of electric field at intersecting point, which is not possible. Okay, suppose two equipotential surface are intersect to each other. Okay, then on the intersecting point there will be two direction of electric field, and at one point the two direction of electric field is not possible. Okay, so two equipotential surface do not intersect each other. Now see the next one, closely spaced in the region of strong electric field and vice versa. Okay, equipotential surface is closely spaced in the region of a strong electric field. Okay, suppose there is a strong electric field, then the equipotential surface are close enough to each other. Okay, and if there is some weak electric field, then equipotential surface are far away from each other. Okay, now our third property of equipotential surface is for any change configuration. Okay, suppose the charges are not linear, the charge is not a point charge, so for any change configuration, equipotential surface through a point is normal to the electric field at that point. Okay, suppose this is your electric field and this is the, suppose this is your equipotential surface and this is the direction of the electric field. Okay, so or suppose this is your equipotential surface and this is the direction of the electric field. Okay, or the direction of the electric field is always normal to this equipotential surface. Okay, and detected from one equipotential and directed from one equipotential surface to the, what will be the direction of the electric field at any type of equipotential surface? Is the direction is always pointed from higher potential to the lower potential. Okay, so at that point and directed from one equipotential surface at higher potential to the equipotential surface at lower potential. Okay, so for any change configuration, equipotential surface through a point is normal to the electric field. Okay, this is the direction of the electric field. Okay, and at that point it directed from one equipotential surface at higher potential to the equipotential surface at lower potential. Okay, now see this in short, equipotential surface is always normal to the electric field. Okay, and what is the second point? Equipotential surface is always directed from higher potential to the lower potential. Okay, now see the next one, no work is required to move a test charge on an equipotential surface. So obviously if there is no potential, then no work will be done for moving an unit positive test charge or any type of test charge from one point to another point in an equipotential surface. Okay, now see what is the next. For a uniform electric field A, okay, suppose there is some uniform electric field A along x-axis. What is the direction of the electric field? Along x-axis. Okay, then here the equipotential surface are normal to the x-axis, that is parallel to the yz axis. See here, x, y and z axis all are perpendicular to each other. Okay, and suppose there is some uniform electric field which is parallel to the x-axis. Okay, so see, equipotential surface is always normal to the direction of the electric field. Okay, so equipotential surface will be parallel to the x, y and z axis. Okay, electric field is parallel to the x-axis. Okay, and this equipotential surface is perpendicular to the electric field. It means the equipotential surface will also perpendicular to the x-axis. Okay, so this equipotential surface will be parallel to the y and z axis, because x, y and z both are perpendicular to each other. Okay, so the properties of equipotential surface is completed up to here. Thank you so much.